When we talk about HMBC, up to now, I only talk in one way, which carbons the proton can see, right? You assume yourself is a proton on one carbon, you look around, you can see the carbons 2 bond, 3 bond away. This is from the point of view of proton. You can list all the carbons specific protons can see. I will do one more examples. Just use this example. I want to show you 2 ways to look at HMBC. Ways. The first way is you can start with proton signals. You list all the carbons that a specific proton can see. For example, we look at proton 2, for example. Proton 2, which carbons proton 2 can see? It cannot see this one because it's HMBC. They will see 2 or 3 bonds, right? Like for proton 2, it cannot see carbon 2. Instead, it will see carbon 1. Right? 1 bond, 2 bond, they will see carbon 1. Right? This is for this direction. For the other direction, 2 bonds, they will see oxygen. 3 bonds, they will see carbon 3. Right? Now you can tell proton 2 can see this carbon and this carbon in HMBC. Proton 2 is here. They show 1 spot here, the other spot here. This spot is carbon 3. This spot is carbon 1. Right? Proton 2 will see carbon 1, carbon 3. This is one way to list. Now, when we say cross-peak, that means proton-carbon correlation. Now we start with a proton. We can list all the carbons this proton can see. In the other words, we can start with carbon and find all the protons this specific carbon can see. We take example of carbon 5, the carbonyl one. Carbon 5. Carbon 5 is here. The proton can see 2 bond, 3 bond. In the same time, carbon can also see 1 bond, or can see 2 bond or 3 bond, right? Now for carbon 5, 1 bond to this carbon, right? Proton carbon 5 to this direction, 1 bond to carbon 4, right? 2 bond to proton 4 or carbon 3. 2 bond. First we say 2 bond to proton 4. Right? 1 bond, 2 bond to proton 4, 2 bond also to carbon 3. and 3 bond to 1 bond, 2 bond, 3 bond to proton 3, right? It can only see 3 bond away, 3 bond to proton 3. This is 2 bond. This will be 3 bond. Right? Now this is to this direction. Now we can say to this direction, carbon 5, 1 bond will see oxygen. 2 bond will see carbon 6, right? 2 bond, they will see carbon 6. 2 bond they see here. 3 bond, they will see proton 6. Now we can say we remove all the carbons because it's a proton-carbon correlation for HMBC. Now we can tell carbon 5, 2 bonds, it can see proton 4. 2 bonds, carbon 5, 2 bonds see proton 4, 3 bonds to C, 3 bonds you can see proton 3 and proton 6. Now you can see carbon 5, they can see 3 protons, 2 bond or 3 bond. 2 bond see proton 4, 5 here, 2 bond see proton 4, 3 bond 3, 6, proton 6 and proton 3. You know, that's why I want to clarify this. For HMBC, the correlation is mutual, right? Proton can see carbon, and at the same time, carbon can see proton. That's why now, for this, you can have 2 ways to list HMBC peak. Proton, it can see how many carbons. For carbon, how many protons it can see. Right? Now we just do HMBC. For this, we analyze all this. After we analyze this one, we finish for today. Now in general way, we start with a proton. We list all the carbons that proton can see. Okay? We don't look at this spectrum first. We look at the structure. We do analysis. Then we will check those HMBC peak. You know, we start with H7, for example. For proton 7, proton 7 is this sp2ch. Now, if you stand on this carbon, which carbon you can see? You look down, you look on your feet, you see this carbon. You cannot see this because this is HMBC. You don't show 1 bond correlation. You will see 2 bond correlation and 3 bond correlation. 2 bond correlation, this CH, 2 bond, you will see carbon 8, right? And carbon 6. 2 bond, you will see carbon 6, carbon 8. This is 2 bond. 3 bond, you will see, because this is a terminal already, no extension. But on carbon 6, there are extension. Now, if you stand on this carbon, 2 bond away, 3 bond away, you will see this is CH2 and carbon 5, right? CH2, carbon 5. This is a 3 bond. Because it can only see 2-3 bond. In that case, that means for proton 7, it can only see 4 carbons. CH2, carbon 6, this is CH2, and carbon 5. Right? Now you draw a line, a vertical line across signal 7. You will see 1, 2, 3, 4. 4 cross peak. You have 4 cross peak. This one corresponding to carbon 5. This one corresponding to 8. This here. This one corresponding to CH2. That's here. This one will be 6. Is here. Now, according to analysis, proton 7 can see 4 carbons. Now we see 1, 2, 3, 4. 4 carbons. They can see 4 carbons. 4 spots, 4 carbons. Now we look at, this is assignment, 7C5, 7C8, 7CH2, 7C carbon 6. 5, 6, 8 CH2. 5, 6, 8 CH2. You find all the carbons proton 7 can see. Right? Now we look at proton 8 here. Proton 8 is very simple. You just stand on this carbon and see one direction, only in this direction. Right? In this case, you stand here, on this carbon, you see 2 more carbons. One is here, the other one is here. You will see 7 and 6. 6 and 7 for proton 8. Proton 8 here, it shows 2 correlation, 2 spots. You see, one is 6, one is 7. You don't miss anything. Now you look at 4, this 4, proton 4. Proton 4, this direction is oxygen, it's blocked. Then you have 2 directions to go. One is 4, 5, 6 direction. The other direction is 4, 3, 2 direction. Now this proton 4 is on carbon 4. It cannot see carbon 4. It will see 2 carbon away. That means proton 4 will see 5 and 6 and 3 and 2. Right? 2, 3, 5, 6. Now you see proton 4 has 4 cross peak. 1, 2, 3, 4. This one corresponding to 2. This one is carbon 5. This one is carbon 3. This one is carbon 6. You have all the cross peak you expected from structure analysis. Now you look at 5, because here is 5. 5 and 5 prime. They are on the same carbon. They should show the same cross peak with proton 5 prime, right? Now 5 is here. That means you can see 2 more carbons beside carbon 5, right? One layer, you can say, you draw just the circles. For carbon 5 is a dot, you draw 2 layers of carbons. Carbon 5 is here, 1 layer, it goes to 4 and 6, right? Another layer, you will see this is CH2, 7 and 3, right? This is 3, 4, 5, 6, 7, 8, CH2. Now this one, you stand on this one, you draw one layer of carbon, that's here. This one and this one, right? Another layer is this. You see here, this carbon, and this carbon, right? You just like, if you draw circles, it's like that. 5, it can see 4 and 6. That's the first layer. Second layer is CH2, 7 and 3. That means for proton 5, it can see 3, 4, 6, 7 and CH2. 5 carbons. Now 5, you see 1, 2, 3, 4, 5. 5 signals. This one is 3, this one is 4, this one is CH2, this one is 7, this one is 6. You have all the expected peaks. The same with 5 prime. Now we look at 2. 2 is here, right? One layer you will see this methyl, and carbon 3. That means one layer proton 2 will see 1, 3, and CH3, right? 2 layer, it see one more carbon further. That means is 4. It can only see 4. Because this direction, only one layer terminate at CH3. And this one is CH2, one more carbon is 4. That means for proton 2, it will see 1, 3, 4, and CH3. Should see 4 cross peak. OH, proton 2 and OH, they overlap here. You see 1, 2, 3, 4, right? The top 2 is 1 or CH3. This one is 3. This one is 4. You have all the peak you expected. Now look at the 3, signal 3. Proton 3, they have more. For proton 3, 3 prime, one more, if you stand on carbon 3, one more layer carbon you can see is 4 and 2, right? Then one more layer, you will see 1, CH3, and 5, right? In that case, you have 1, 2, 3, 4, 5. For proton 3 and 3 prime, they will have 5 cross peak. Now you count 1, 2, 3, 4, 5. 5, the top 2 are methyl and those 2 methyl, and then this one is carbon 2 here, then this is carbon 5, and this is carbon 4. You see all 5 peak you can see. Now you look at proton 1, for example. Proton 1, one layer, it will see 2, right? 2 layer, you can see this methyl and this. 2 bond, 3 bond, 3 bond. Then for methyl, you will see 3 cross peak. One is 2, the other one is 3, the third one is CH2. You see 1, 2, 3, right? This one is methyl, this one is 2, this one is 3. That means for HMBCP, you will not miss anything. This one is a very good example of HMBC. You can observe all the peak. But sometimes you may miss something. As I mentioned in the beginning, for 2D NMR, for the detour drawing, plotting, and they reduce the intensity. In that case, they can remove some peaks. But in this case, you don't miss any peak. You have all the peak expected. This is just analysis. If you draw one line, that means this proton can see how many carbons. If you draw horizontal lines, that means for this, for example, for this CH2, you draw one horizontal line, you will see you have 1, 2, 3. You have 3 protons. That means this carbon can see 3 protons. CH2 is here. It can see 5 prime here, right? And also 7, right? That means CH2, this CH2 can see this proton and this 5 and 5 prime. Anyway, if they can see each other, at most, they can only be 3 bond away, right? Okay, we will spend time for the next lecture for nosy. I will give a few examples of nosy for the next lecture, and also